Here you can see a 5-axis wire and arc robot. In simultaneous 5-axis wire and arc additive manufacturing, the machine nozzle has 3 linear axes, X, Y, and Z, and 2 rotational axes, A and B, all engage at the same time to perform complex processing on parts. Additive manufacturing for metal part can be divided into 2 different types: the powder technology and the wire technology. Usually, powder is adapted for fine components and small parts, whereas wire is used for structural components and large-scale parts. One of the main benefits of additive manufacturing is to simplify assemblies by reducing the number of components and to provide a large freedom to design. A standard additive manufacturing system consists of the combination of 3 blocks: a motion system, a heat source, and a feedstock. For wire and arc additive manufacturing, the heat source is a welding generator and the feedstock is a wire. The motion system generally used in a 6-axis robot or a CNC machine. Equipment cost, high material utilization, and consequent environmental friendliness. The origin of the Waam process can be traced back to the 1925 when Baker proposed to use an electric arc as the heat source with filler wires as feedstock materials to deposit metal ornaments. Since then, consistent progress have been made on the development of this technology, particularly in the last 10 years. Today, Waam has become a promising fabrication process for various engineering materials such as titanium, aluminum, nickel alloy, and steel. Compared to traditional subtractive manufacturing, the Waam system can reduce fabrication time by 40 to 60% and post-machining time by 15 to 20% depending on the component size. For instance, recent breakthrough in Waam technology have made it possible to fabricate aircraft landing gear ribs with a saving of approximately 78% in raw material when compared with the traditional subtractive machining process. Due to the highly complex nature of Waam, many different aspects of the process need to be studied, including process development, material quality and performance, path design and programming, process modeling, process monitoring, and online control. Here you can see different universities and different research groups around the world that are working on wire and arc additive manufacturing. In the Europe area, Nottingham University, Sheffield University, and Delft University of Technology are the main universities that are working on the development of Waam process. Waam processes use commercially available wires which are produced for the welding industry and available in spool form and in a wide range of alloys as feedstock materials. Manufacture of a structurally sound, defect-free, reliable part requires an understanding of the available process options, their underlying physical processes, feedstock materials, process control methods, and an appreciation of the causes of the various common defects and their remedies. As you can see here, wire and arc additive manufacturing is a layer by layer additive manufacturing process. After the first layer deposition and solidify, next layer starts to deposit on top of the first layer, and then by iterating of this process you can finally reach the ultimate desired shape of the sample. This is a bicycle produced by Waam process. This bicycle has fabricated by MX3D company in Amsterdam. This is the first bridge that completely produced by 3D printing. Also, this bridge is in Amsterdam. this is 5-layered deposited on a substrate. And this is the final simple sample, a wall sample.